So we've seen recursive rules, we've seen explicit rules, and sometimes it can be a little bit tricky to come up with these rules for the sequences. Well, if we have a special type of sequence called an arithmetic sequence, I know it looks like arithmetic, pronounced arithmetic, but if we have one of these special sequences, writing the rule is pretty quick because they all follow a very unique pattern. And we know that a sequence is going to be arithmetic if it has terms separated by a common difference. Now, difference means subtract, correct, ladies and gentlemen? So the way we find that common difference, we take any term and subtract the term immediately before it. So common difference, term 2 minus term 1. And that better be the same as term 5 minus term 4, or term 3 minus term 2. And that difference needs to be in common between all of the terms. Now, quick side note, arithmetic progression, you might see that written in the textbook, written on an exam, written throughout your life, tattooed on your arm, something of that nature. But the arithmetic progression means the same thing as arithmetic sequence. Progression means list of terms. So let's come up with the rule for this. Let's say we have a first term of A1. What would be the second term if we have a common difference of D? Well, the second term would be the first term plus the common difference. How about the third term? Well, that would be the second term, A2, plus the common difference. I'm going through this recursively right now. Well, the first term was really A1 plus D. And if I add another D, isn't that really the same thing as A1 plus 2D? Okay. How about the fourth term? Well, that would be recursively thought of as the third term plus the common difference. Well, the third term was A1 plus 2D plus that D right here. So this simplifies to become A1 plus 3D. So what are we seeing? Are we starting to see a pattern emerge here? No? Okay. Well, let's try the fifth term. That would be the fourth term plus the common difference. And the fourth term was A1 plus 3D plus this common difference. So this would be the first term plus 4D. Seeing a pattern yet? Well, let me highlight a couple things. Second term, add D. Third term, add 2D. Fourth term, add 3D. Fifth term, add 4D. See if you can't venture a guess as to what the rule would look like if I was looking for the eighth term. If you guess that it's A1 plus 7D, you hit the nail on the head, ladies and gentlemen. And if you're feeling real bold today, let's see if we can't generalize a rule for the nth term. Pause the video, try and write down a rule that looks similar to what I have right here, but involving n instead of an actual number. So it's going to be the first term plus, now how can we describe how many times we're multiplying by D? Well, for the fifth term it was 4, the eighth term it was 7. So for the nth term it would be n minus 1 times D. And this right here, ladies and gentlemen, this is a wonderful, wonderful thing. Every arithmetic sequence is going to follow this type of rule. So if we know the first term and we know the common difference, we can write an explicit rule very, very quickly, very, very efficiently. Let's do some problems. let's look at how we can use this in what we'll be working on. So the fifth term is 7, A5. The eighth term is 16. Write an explicit rule for this sequence. Okay, we know that it's arithmetic, which means an equals a1 plus n minus 1 times d. Let's plug in what we know here. So for the fifth term, we can write 7 equals a1. We don't know a1. Plus n minus 1. Well, n is 5 for this one. So 5 minus 1 times common difference. We don't know that either. 7 equals a1 plus 4d. Okay. We don't know a1. We don't know d. We can't write a rule yet. So let's take this eighth term and do the same sort of thing. An is our 16 equals a1 plus 7 minus 1, or sorry, 8 minus 1, which is 7. Well, we have two equations with two things that we don't know. Well, we know how to deal with that. Let's take them, stack them on top of each other. And use elimination to get one of these variables alone. I'm going to multiply the top equation by -1. That becomes -7 equals -a1 minus 4d. Adding the two equations together now, we get 9 equals 3d. Divide by 3. d is equal to 3. Now we're halfway to being able to write an explicit rule. We still need a1. Well, we can use either one of these pseudo rules back here to find that first term. I'm going to plug it in to the 7 equals a1 plus 4d. It has smaller numbers. I like small numbers. So 7 equals a1 plus 4 times 3. 7 equals a1 plus 12. a1 is going to be -5. So my rule, ladies and gentlemen, here we go. Here's what we paid the money for. An equals -5 plus n minus 1 times 3. Now, my personal preference and what I would like you to always do when you write an explicit rule is write it in simplest terms. So we're going to distribute 5n minus 3, and we get our explicit rule to be an equals -8 plus 5n. There's my explicit rule. I can turn and use this to find the 100th term. So this is -8 plus 500. So the 100th term is 492. For these problems involving sequences, if you can get a generic explicit rule written, you really can do anything. So I encourage you to take that step, to take that strategy as you go into these problems. Always get a rule written, then try to answer the questions that you're given. So here we go. An arithmetic progression has first term 5 and common difference 7. What is the number term corresponding to the value 355? Okay, so we need a rule. We always need a rule. No question about it. We have a sequence. We need a rule to answer this question. The nice thing is, they tell us the first term is 5. The common difference is 7. Aren't those the two things we need to write an explicit rule? An equals a1 plus n minus 1 times d? Heck yeah, we got what we need. An equals 5 plus n minus 1 times 7. Let's simplify. Our explicit rule is an equals -2 plus 7n. Here they give us a term and ask us for the term number. So where do we put a term? We put a term here. This is the actual term. So we're going to write 355 equals negative 2 plus 7n. So we have 357 equals 7n. N is going to be 357 divided by 7. And I seem to have misplaced my calculator. But if we were to divide those numbers, we will get our term number. And this tells me this is equal to 51. So the 51st term is 355. Don't believe me? Start with 5 and keep adding 7 51 times and you will get to this term. And there we go. But basic strategy for using sequences. Come up with the rule, then use the rule. And that's all I have for you today. Have a lovely time.